So we're covering those very, very basic stuff today. Try to memorize as much as you can, but the more you read the book, the more examples you try. You definitely have to try at least some examples. The more quizzes you take, the more it's going to stick in your head that, hey, there's a console output device which I can use. There are character strings that I can use. And the syntax is this or that. And so that should be helping you out as the time progresses. So if you're a little bit overwhelmed today by looking at some of the things that I do here, don't despair. You can watch it on YouTube, hopefully. It's going to get all posted well and appear on YouTube within the nearest few days, like Wednesday, and you can watch it again, and I'll give you some tips later on. Now, here's another example that we can actually copy and maybe paste into that C++ shell. I'll give you a tip here that sometimes when I go here after being after like idling for a while, that if I had this window open for a while, it somehow doesn't respond too well. So sometimes it doesn't hurt just to hit refresh and just go back. And so let's just copy and paste what I had over there. Okay, and so over there, there's another example from our slide. So we'll just I'll just try to keep the format consistent. I like to add some extra white space to my programs because they just look nicer and it's easier for me to see what's going on. We call it programming style. The way you add white space, you can, as you're gonna see me more and more typing things in, you'll see that I have a certain style, the way I place white space around things. And anyway, just to tell you that. And so here's another example of using cout, which is standard character output device, automatically given to any program to use because it's just like, this is standard. That's what you deserve to get just because you were able to write a few lines of code like that. And it says, so I'm trying to create a variable named pi. Okay, so is pi initialized or uninitialized? What do you think? Is it initialized or not? Yes, it is. Yes, right. Because we say, oh, look, it gets the value, and it's, of course, 3.14 and so forth, right? Then the value of pi is going to be stored as double. Double stands for double precision point floating decimal floating point variable. So it basically stores a real number that can have fractions, decimal fractions. So obviously with certain precision we have here 3.14 and so forth. That's looks like a number with fraction. So double is your first choice in traditional like financial applications, anything you do for business. If you're writing a video game, you'll use a float. Float is another type of a number, floating point number, which is available, which basically is 2 times shorter, usually 4 bytes in size, but it creates a perfect choice for video or 3D graphics programming anyway. So like your colors, your textures, your coordinates, your worlds, everything is pretty much represented by the floating point number, to tell you the truth. So anyway, so we have those 2 choices. I'm going to refer back to double. Okay, so double stands for double precision, which usually is 8 bytes in size. And if we run that in this environment, hopefully it compiles and runs, it just does the same thing, kind of silly. It says pi equals 3.14159, which basically displays a shorter version of this fraction because cout is programmed to round things up and sometimes give you a different precision. But I'm not going to talk about this right now. The fact is that it actually does work, and this is an example of a different, of a global variable of a different type, double floating point precision data type. Okay. So moving on, so we say that this area, initialized and uninitialized areas, are basically global data, okay? Now, on this picture, it says initialized to 0 by exec. Exec, by the way, a C function call which allows you to execute other programs, okay? So there's a system function call called exec, and you give it a path to an existing program, and it'll actually load it and start executing it, okay? So that's why it says exec, because operating system internally does something like exec thing to execute your own program. All right, so just a few more notes. Perhaps I can switch to this view again, to C++ shell view. Here we say that main is a function because it's using a rounded parentheses in its syntax, and function is basically like a little universe or a little island that hosts some executable code. And my executable code is here enclosed between two curly braces, okay? So that's called the body of the function, and the name of my function is main. And if you were present last week in your Java class, you know that main stands for main entry point into your program. Okay, and Pi here represents a global variable. Okay, and we say that the executable instructions which are needed to run this program will be placed in this text memory segment, whereas the global variable will be placed into either initialized or uninitialized, depending whether you do initialize your variable or not. Okay, so moving on. So we already kind of mentioned this already, so we can skip forward. And here's stack memory segment. So stack memory segment is something that contains local variables. Let's use our example here right away. And to tell you the truth, global variables are viewed by say Java and C++ design principles as evil. They're bad, okay? There are multiple reasons why they're bad. In fact, I can assure you that whenever I see a project that I have to work on and it's making use of multiple, many global variables, usually I put myself on alert because they come with lots of things that you have to watch out for. The reason for this alert is that global variables are not protected in any way, so that they can be modified by any part of the program at any time. And sometimes when you look at the written program and you see that this global variable is modified, and in a different part of the program there's an if statement that tries to analyze the value of that variable, there's absolutely no way for you to know what value really is going to be analyzed and what to expect, because you just don't know when that happens, right? If statement could be executed before that other place changes global variable, or vice versa. The global variable can be changed and then the if statement executes. It's very difficult to know. So to make sure, you actually have to run the program and try to basically watch out what really happens. It just always takes extra effort to understand how global variables really behave in the code. So best advice, simply not using them. Look, there's absolutely no need to make this variable global, because I can basically cut and paste this right into my the body of my function main right here and make it a local variable. How do I know that this is a local variable? I know that it's a local variable. Another name for local variables is automatic variables. Is that it is created and it exists inside the scope of main, right? Main, with its curly braces, with its pair of curly braces, essentially fences in this variable, and it gets created only when main executes. Okay, so anytime main is called, a local variable named pi inside main, inside the scope of main, will be created. And we call them local variables because if I had another function like, I'll give you an example, like integer do stuff, right? Something like that, which trying to format this, which says return, I don't know, return return 1, 2, 3, kind of silly stuff, right? So if I wanted to say integer, or if I wanted to say this, std cout, I know I can use cout to print things, okay? And I say std cout pi, okay? This will fail miserably. If I run this, it's going to say, I have no clue what pi is, okay? Because pi doesn't belong to the scope of do stuff, whatever do stuff is. Do stuff has its own little universe between its own curly braces, and it has no clue that there's double pi anywhere in this program, right? So that's why we call them local variables. Their visibility is reduced only to the set of curly braces. You can use pi here, but not anywhere else. Sometimes you will want to share a variable like pi with the rest of your program, and that's the topic for another discussion. It can be quite possible and doable, but right now the default rule is that the visibility of pi is reduced like that, right? So if I wanted to, right, I could basically copy and paste this here as well and say, hey, okay, I will give you another double pi, and this way it'll be fine, it'll be okay, right? It will compile and run, but you should realize that this variable and this variable are absolutely two different variables, okay? Despite the fact that they have the same name, uppercase p and lowercase y, pi, right? They're completely two different variables, and they exist at different memory addresses. And even their life cycle can be extremely different because, look, we said that execution of the program begins in main, right? Whenever that operating system loader puts your program in memory and says, hey, start executing, and it starts executing, main has no mentioning here of do stuff at all, right? It has no connection to do stuff anyhow. Well, guess what? Do stuff will never execute, okay? Never execute, and therefore this copy of variable pi will never be even created. There will be never any time wasted doing that, because who knows, yes, there is code, but it never gets to execute. In fact, so if I run this, right, so pi gets printed only once right here by this statement, okay? But if I wanted to do the second time, I would have to say do stuff, right? I have to make a function call and say, hey, I want this to execute in addition to whatever that does, right? So let me add some message here and say sometimes it's very useful to say, in this function, I'll give you a tip that every function knows its name, and it's kind of funky looking underscore underscore function underscore underscore, right? 2 underscores, function, uppercase, 2 underscores again. So in whatever function name is, I will say pi is, and it's going to tell me what pi is, and I will add another new line, okay? So this is kind of weird looking statement, but you will see what it does. So when we say run, okay, it says pi equals whatever this thing is, okay? Then we connect with do stuff. We invoke do stuff from main, and it creates its own version of local variable named pi, and then prints in function do stuff, okay? And apparently I need to add a space here to keep things separate, right? So we say run again and say in do stuff pi is this, right? But we could have kind of initialized it to 3.1 to reduce the precision, so you can see the difference. And here is a horrible precision for pi, 3.1, but you can see that it's a different variable that gets printed, okay? But just give you a tip that it's very, very convenient sometimes to say that, oh, what's the name of the function? Can I print it? Well, you could have like hard-coded, but this is a very useful type of thing to know that you can print things like that. All right, we actually went way too far off the very basic stuff today, but it just happened to be the case. But the discussion started with the fact that anything that you do inside those curly braces, and those curly braces in our case represent the stuff that belongs to our functions, which is main and do stuff. Okay, we have 2 functions in this program. So the scope and visibility and life cycles of variables that we create inside those curly braces is completely limited to these function calls. Let me do a quick, one more quick demonstration here. I can call do stuff many times like that, okay? Just copy and paste and call it like 5 times, okay? Well, guess what? This variable pi is created and destroyed 5 times. So, which is kind of normal for local variables, okay? And that's what happens. You can see when I run it, I get the same output for do stuff like 5 times on my screen, okay? And it does happen, but I can assure you that this variable pi is created and destroyed 5 times. It is created, used, gets the printout, gets destroyed, because function returns, and then we start all over again. Yes, question?
How come you can print out